This video briefly introduces random variables. What is random variable? Well, random variable, in short, they are functions. Here, we use a simple example to show the construction of these random variables. We know probability values. They are normally assigned with random events to quantify how likely a certain event happens. Random events have sets of outcomes. As shown here, if we consider a simple exercise, throw a coin. For n times, we might consider the following two events. Event A1I denotes the event containing all the outcomes such that the nth throw gets a hat. And A2I is a complement event of A1I, so it denotes the set collects all the outcomes such that the nth result is a bottom, is a tail, right? Those random events are sets, and manipulating random events requires operations concerning sets, and it would certainly be much easier if we work with numbers instead. One straightforward way of thinking would be, well, let's link these events with numbers. For example, here, we let xi equal to 1 if the nth row gets a hat, and 0 otherwise. So through xi, we link events with numbers, right? And with the second set of notation, we can do more things in easier ways. For example, think about what would happen if we let n increase in the following formula, the sample average. Okay, we know xi could take either 1 or 0, so the sample average could also take multiple different values, right? Because each xi within this formula could either be 1 or 0 with half-half probability. But based on our daily experience, we know this sample average is going to be more and more likely to be closer and closer to half as we throw in more and more times. So with the second set of notation, we can simplify a lot of things. And if you want to express similar ideas with the set operations, it's going to be a little bit messy, I would say. Not as easy as working with numbers. Now let's take a look how the xy is constructed. If we formally look at the way xy is constructed, we see that it is essentially a function, right? Maps outcome to 1 as long as the outcome is from A1I and 0 otherwise. So we have the domain, we have the codomain, which is 0 and 1, and we also show the relations, right? How this function links the outcomes to the numbers 0 and 1. So this is a specific example to show that random variables are essentially functions. And at the same time, we could use random variable to generate the event. For example, we use this notation, xi equal to 1, denote the event containing all the outcomes such that this xi function would map those outcomes to 1. So essentially, this xi equals to 1 event is equal to a1i, right? Because it contains all the s such that xs would be equal to 1, which means this set would be equal to a1i. And easily we could apply assign the value to the probability of such event with the value of the probability of event a1i, which is half. Right, so here we have a function, which is the random variable maps the outcomes from sample space to numbers. And we know probability function would assign values within 0 and 1 to events. And here, similarly, we could have probability values assign values within 0 and 1 to events generated by the random variable. Okay. So x is essentially a function, and we know there are so many ways that we can manipulate functions, right? We can work with summation of two functions. We could divide one function with another one, and we could manipulate exactly the same way with random variables to consider the sum of two random variables, or use one random variable to divide by another one, consider the maximum or minimum among multiple random variables. They again generate new random variables. Okay? And we can also use events generated by random variables now, and we have probability functions to assign values within 0 to 1 to those random events. Given the introduction of this of these random variables, we have additional structures. Now we have a much larger space to explore. Previously, we might consider conditional probability or independence based on random events. Now we could consider the same concepts based on random variables, right? To generalize them to cases dealing with random variables. And we can also study what kind of special properties assigned with different random variables, because random variables are functions. There are selected functions with nice properties. So there are also some selected random variables. They are very popular, widely used in our daily life. They got special properties. They have their own names. So basically, the introduction of random variables opens a door to a much larger space for you to explore. And this video barely provides a touch of the beginning. Thank you for watching this video.